Hello everyone, and like I promised yesterday, today I just want to show you how to estimate the NDVI in QGIS using Landsat 8 satellite imagery. And I already provided the satellite imagery in class, so all of us have access to the data. But if you don't have access to the data, you can actually download the imagery from the USGS GLOVIS Explorer or GLOVIS portals. Okay, I showed you the USGS Explorer, and I hope that everyone registered and you have access to the platform. You can learn more how to download the data from the USGS Explorer by simply going through the manual or watching a few videos on YouTube, or you can watch the videos as indicated on the exercise document that I provided. Okay, so in this case, I want to demonstrate how you import the satellite imagery into the QGIS platform. So you basically go to the data source manager here. And since we are dealing with raster dataset, we go to raster, click on raster, and then we navigate to where the data is stored. I provided about 5 bands, but in this case we'll just need, I think, band 5 and band 4. I will explain. I'll show you the formula for the NDVI. So we bring it in the QGIS environment. Now, to estimate the NDVI, to calculate the NDVI, here's a formula. Okay, so the normalized difference vegetation index is a vegetation index that is used to monitor the condition of vegetation or vegetation health. And the NDVI is the most commonly used vegetation index for monitoring vegetation globally. Many other vegetation indices, such as the enhanced vegetation index, the ratio vegetation index, and perpendicular vegetation index (PVI), they take into account the soil emissivity, one of the major limitations of NDVI. So, depending on the information you want to generate or what you're really looking at, you can use the different vegetation indices other than the NDVI. But generally, for most purposes, the NDVI should suffice. Okay, so the NDVI measures the difference between the reflectance of near-infrared and visible red light, indicating the amount of chlorophyll in plants. This has implications on understanding the water status, the water stress status, then also the plant health in terms of disease or any other condition that you are trying to assess in vegetation. So the NDVI values range from -1 to +1, with higher values typically signifying denser and healthier vegetation. And you will learn more about the NDVI in class. And so the formula is near infrared minus the red light, and then divide by the near infrared plus the red light. Now, depending on the satellite imagery that you are using, if it's Landsat or Sentinel or Raster or whichever that you are using in your assessment, you need to check which bands correspond to the near infrared, and then also which band correspond to the red. In the case of the data that we're going to use, which is Landsat 8, the near infrared band is band 5, and the red band is band 4. You are provided with band 2, band 3, band 4, band 5, and band 6, okay? But in this case, we're just going to use band 4 and bands 4 and 5. So now we can go back to our QGIS and see how best we can estimate the NDVI. We are going to learn in detail about the NDVI in class, and this is just an exercise on how you can calculate the NDVI. And by the way, you will have an exercise where you're going to download the various satellite imagery using the semi-automatic classification plugin that you installed on your QGIS. Then also using the USGS Explorer and many other platforms. You are going to have an exercise on how to access data from those platforms. And mind you, there are several platforms where you can access this data. So it's not just these two platforms, okay? A number of platforms are available, and you can access depending on your needs and availability. Okay, so we go back to QGIS. And here in QGIS, we have bands 4 and 5 of Landsat 8. Okay, from 2025 in July. It was taken in July of this year. So that is in the dry season. So of course you expect differences in terms of the NDVI for the rain season and for the dry season. And if you probably want to do a time series analysis, you can also look at monthly NDVI or weekly or bi-weekly NDVI and see how the changes are, in terms of the plant health or plant water content, and so many other variables that you may be interested in. Okay. Now, in this instance, we are interested in just understanding, or rather estimating, the NDVI. So to do that, we come to the menu here, the menu bar, and we click on Raster, and we come to Raster Calculator. Okay, mind you, our formula is near infrared minus red divided by near infrared plus red. That's band 5 minus band 4, band 5 plus band 4. And so we start our equation. So you double click on band 5, then you click on the minus sign, and then you double click on band 4 and close it. Then you divide by, click on band 5, and then plus, sorry about that, plus 4. Okay, so once you've put in the equation or an expression, if the expression is valid, you will see here it's being indicated that the expression is valid. Your equation has been typed correctly or has been inputted correctly. Okay, so then we need to indicate where we're going to save this output, or the NDVI layer that we have estimated. So you go to the browser, click there, then we go to where I want to save this. In this case, let's save it here. Okay, NDVI, I'll say MU class. Okay, it is saved in JOTI format. Okay, take note of the coordinate reference system. Okay, that is EPSG 36, 635, WGS 84, UTM zone 35. This is not 35 north, it is 35 south. But don't worry about that for now. Let's just click on OK and see what we get. Okay. So we have our NDVI estimated or calculated. Remember, we said the values range between -1 and 1, and here we have values ranging between -0.102169 and 0.548735. Okay, so this is within the range that is expected. So then we can also just change the color and see how it comes out. Okay, single pseudo color, and let's see how this comes out. And we go to classify and apply. Okay, so we see that the areas that are green here are indicative of the vegetation that is really is in good condition or has high water content. And by the way, like I mentioned yesterday, this can also show you the areas that are under irrigation. So basically these crop fields under irrigation. Okay, and then these others could be they've already maybe they are harvesting or they've already harvested, and then you have these others that are still being irrigated. And the deeper the green color means probably they've just been irrigated, or the vegetative state at which the crop is one that has a lot of water at that stage. Or it could also indicate that the crop is about to be harvested, or the vegetative state at which it is, or it's at maturity stage. Okay, it's at a different stage. So different stages will give you a different NDVI assessment, or NDVI outlook rather. Okay, so then we want to go to Mulungush University, and our university should be somewhere here. Okay, let's bring in the HCM GIS and get the base map. Okay. I'm not connected to the internet. Just a moment. So like I mentioned in class, for you to get to have access to the best maps, you need access to internet. Remove this. Okay, maybe let me just click on the X. Okay, so Mulungush University is here. And I want us to look at the NDVI for this area. Okay, so then I have to move the layer to the top. So Mulungush University is here. Okay, so what this means is that as at July 30, 2025, possibly the other fields were not under irrigation, except for these where you can see a lighter green color here. Okay, so now for us to get the NDVI for a particular area of interest, we need to bring in the shapefile for that area. Then we can clip the NDVI to that area. Okay, so in this case I'll just do a quick one. Rungush University is somewhere here, and I'll create a layer just to for use to clip out the NDVI or the raster. So we can go to layer, create layer, a new shapefile, and we can give this a name. And okay, so we can say NDVI boundary layer. That's okay, just for exercise. Leave the other attributes the way they are, then it's polygon. And if you remember, our coordinate reference system is not this one, so it has to be the same as the coordinate reference system for our raster. So we can come here and click on the raster or the project coordinate reference system. Or you can also define this coming back here, okay? Because we are in UTM zone 35 south, not 35 north. Okay, so you can click there and then just a bound thing, the sake of. Okay. You already know how to create shapefiles, as in polygon shapefiles. So this is just the sake of the exercise. And to create the shapefile, we go into editing mode. Okay, so we click there on the layer that we want to edit, move it to the top, highlight it, then toggle editing, and then we activate the add polygon feature. We want to digitize by with segment. Okay. So then we can simply do this. This will include everything under Mlungush University. Okay, one. Okay, so we save it and we move out of the editing mode. All right, so now to clip this raster to the boundary that we have created, we simply come to the menu bar, toolbar, and then click on raster and come to extraction, extract clip raster by mask layer. Okay, click there. The input layer that we want to clip is the NDVI MU class, and the mask layer is the layer that we've created, which is the NDVI boundary layer, which is here already. And these we can leave them the way they are. And the output layer is going to be saved somewhere here. NDVI clip 1, or basically NDVI MU clip, and save. After that, we run. Okay. About these other attributes or properties, you can set them as need be, as you desire. Then on the output data type, you can also check the data type that you're dealing with. Okay. For instance, you go to properties and you go to information. You are dealing with data type float 32, the 2-bit floating point. Okay, so you can also set this the same way. If you want to have it the same as the output raster, you can set it to float 32, the 2-bit floating point. Okay, so here you can change to 32, this one. the two floating point. But even if you leave it blank the way it is, use input layer data type, this is okay, because then you are just getting what is already existing in the NDVI that you created. But if you want to change, you can also change basically by coming here and changing the data type in the output. Okay, so after that you click on run. We should have a clipped raster, and if we remove that, we have a clipped raster. Then we can remove this part and also our Google satellite. Then we can change the color and see how it comes out. Go to symbology and single band pseudo, use the same one. Then maybe we can reduce the precision to 2 and click on apply. Okay, so now you see our NDVI okay, so you can tell which areas are under irrigation. Okay, this is in July, it's in the dry season, so basically the crop fields that you are seeing there are under irrigation. And like we did the exercise we did on digitizing irrigated cropland, you can actually digitize these crop fields and indicate the area that is being irrigated in your given location, your camp, your district, and your province. Basically, using the NDVI, you can get to know the area that is under commercial irrigation. Or if you have a particular location where small-scale farmers are doing irrigation, you can zoom into that area, and you can also digitize the area, and you should be able to understand the hectareage that is under cultivation. It may not be possible to understand the crop type, although, excuse me, if you are capable of, maybe if you're using Sentinel satellite data or any other high resolution satellite data, you should be able to identify a few things. If it's cabbages, you can differentiate cabbages from any other crop, okay? And so you should be able to digitize that and say this is cabbage fields, and this is maybe say corn fields or maize fields. Okay, I think this is how far we can go for now. And like I mentioned earlier, the higher the NDVI value, it is indicative of the health of the plants or the vegetation that you are looking at. Okay, so in this case, for instance, we can also determine, we can have an idea on which areas of the fields need to be irrigated or have crop that is stressed, or that is has a disease or is going through a different condition from the rest of the field. Okay, if the crop is evenly irrigated and it's also in good health, you should have an even green color here, for instance. Okay, if there are any differences in the color, that could be indicative of different things. Either the water content is different, maybe the other parts are diseased, or they are drying out, and so many other things depending on what is really going on. Okay, all right, so this is how you estimate the NDVI using Landsat satellite data. But you can also use many other data sets, MODIS, Sentinel data. You can also use drones. They can give you the imagery that you need to estimate your NDVI. And that should be able to give you information about a number of factors, a number of variables that you may be interested in and use in the management of crop fields. Okay, you can also use this NDVI to monitor maybe can I say pollution? Maybe if say there was pollution in a given landscape, and maybe say oil spill or a certain chemical was disposed of in the environment, and there was rain, and it got into the soils, the plants got this chemical and it's affecting the plants. If you do, you perform your NDVI analysis, you should be able to detect some of these things, the changes before the accident and after the accident, and also the time of the year. All those factors, if you are to take them into consideration, you should be able to pick out a few areas or a few signs to tell you that this this landscape or this type, or rather this vegetation has been affected by this pollution. But again, it's just an idea. For you to really be conclusive, you need also to have field data. So field data should be able to validate what you are seeing using the satellite data. Okay, so for this exercise, I think we can end here. And I think it would be easy if it came in a practical exam. You should be able to easily calculate, estimate the NDVI, okay, and be able to say a few things about what you estimate, the NDVI that you've estimated across this landscape that you're looking at. Okay, so if this came in the exam and you were asked to estimate the NDVI and then digitize all the irrigated cropland and estimate the area of the cropland and produce a graph to show the area of the cropland that is under irrigation. Okay, you can perform analysis, various analysis. Okay, so thank you.